Okay, so in this chapter, we're going to be talking about file input and output. We're going to show you how to do some files, the different types of files there are. We'll show you how to handle some exceptions and read and write to a file. Okay, so there's a couple different types of file types. I mean, obviously you've seen .txt, .jsv, .java, .html. You've seen a gazillion of those. Most of those are text files. Text files are anything you can open with a text editor. That's considered text files. You can open it up and understand most of it. I mean, not necessarily all of it. Now, a binary file is like a zipped file or an MP3 or an exe. These have to be opened with specialized programs. In this particular unit, we're going to be concentrating mostly on text files. We'll show you how to open up a text file and save your data, or like suppose you wanted some sort of saved game. You want to save the number of lives you have in some sort of game. You could use that by saving that information to a text file. And that's what we're going to show you how to do. Okay, there's two different types of file access. This is probably something you've gone over in your 1030 class, but we'll just review it again since we're about to do this. You could have a sequential access file, which basically accesses the information in order, kind of like a cassette tape. Or you could have a random access file, which allows you to jump anywhere into the middle of the file to be able to access the information. I'm going to give you kind of a visual of this. Here I have a box of tennis balls. If you want, this is going to be similar to random access. If you wanted to remove ball 3, all you would have to do is reach your hand in there and grab ball 3, and you knew exactly where it was. You could remove it, you could replace it, you could do whatever you wanted with it. Now let's compare this same example to a sequential access. If I want to access the third tennis ball in this, how would I get it out? Well, in order to get ball 3 out, I have to first remove 1 and then 2, and then I can access ball 3. So this is kind of like a sequential access file. In order to access any of the data in the file, we have to start at the top and iterate down to the value we want to get. So here's an example. Suppose we wanted to access, we have a little text file and it has some food in it. I don't know why I'm always thinking about food in my examples. I must be just like perpetually hungry. Anyway, suppose we want to get the donuts and we want to access this value in our shopping list.txt. The very first thing we'd have to do is read out apples. As soon as it reads out apples, the pointer for the file would move down a tad and we'd access bananas. Then we could get cheese and then donuts, and then finally we're there. And so that would be, if we wanted to continue reading, we could read on to eggs and then read the entire file, or we could stop at this point because this is the value we were originally looking for. Now, you want to watch out. There are some things called dangerous code. Dangerous code are situations that you could run into that would cause your program to crash. In that case, you'd want to provide some sort of exception. Now, here is an example. Suppose the file that your code was opening was called shoppinglist.text, and the file name on your computer was called shoppinglist.txt. See how there's like a slight discrepancy in these two files with that E here and missing over here? It doesn't matter which you name it, this is probably preferred over here with the TXT. However, this would cause your program to crash if you tried to open a file that didn't exist. And so we would have some sort of exception. There's our, forgot it. This particular exception is called a file not found exception because it can't find the particular file it's looking for. Now there's other types of exceptions. Here's another example of an exception. Here I have a system.out.println statement that has them enter a number, and the scanner is reading for a number. Well, what would happen if they enter in the value for pi, 3.1415? It's stored in an int. Or what would happen if they entered in their name? Bob or something like that. That would be dangerous code. We've been coding dangerous code this entire time and you haven't even thought about it. But this is considered dangerous code. We'd have to provide some sort of exception. In this particular situation, it would be an input mismatch exception. That's the type of exception you would have in this situation. And there's lots of different exceptions for all of the different values. Here's another one. I have a list. Here's my array, and I've got 0, 1, 2, 3, 4, 5. My list size is 5. My positions are 0 through 4. What if I tried to print out position 504 in this list? This would crash our code. That's dangerous code. So here, there is no position 504, so we couldn't do that. That's dangerous code. That's considered an out-of-bounds exception. Now, what exceptions do is they're just abnormal conditions. They might be logic, they might be user input conditions. It just happens. But what happens is it disrupts the normal flow of your program. Here, let's give you an example. Suppose I have a bunch of statements of code, and then I run, and when I run my code, I have an exception that occurs on statement 4, and that crashes. So at that point, it skips statement 5, 6, 7, 8, and 9. It doesn't ever run them. And that's the problem with our dangerous code, is if the exception occurs, the code following is not executed. But there are times when we have to have some of that code executed. For example, when we're dealing with files, every time you open a file, you have to close the file. Now, if your exception happens while that file is open, then that file never gets closed and you could end up with some memory leaks. So we are going to show you a way to deal with some dangerous code. And we do that using a try-catch. Try-catch handles exceptions. Now it's kind of like an upside down if statement. On an if statement, you say, if this situation is true, then run this code. In this situation, it's try some dangerous code using this try right here. And then if something happens, it's going to catch the exception. In this particular syntax, I'm catching just a generic exception, so it will catch anything that happens. If you want to be specific in how you handle the exceptions, you can break it down and you can say, I'm going to catch a file not found exception, I'm going to capture an input type mismatch exception. You can break it down, but this will just handle every exception. And then any code you need to happen, if that dangerous code crashes, you can put into your catch. So here is an example. Here I've got a system.out.print statement, and I have 10 divided by 0. Well, everyone knows that you can't divide by 0, so that is dangerous code, actually. So if I were to run this code, it would never display this system.out.print statement that says rest of code. So there's our arithmetic exception, and rest of code never gets implemented. In this situation, I've got the same exact situation. I'm still dividing 10 divided by 0, which is illegal. It's still going to be dangerous code. It's going to crash my program. But in this situation, it's still going to print out this statement because it's in our catch. It catches the exception and can continue on with our program. All right, now you can have multiple exceptions. How I was telling you, you could catch more than one exception at a time. So here, I'm going to have a code. This is just pseudocode, so we'll show you the actual code in a minute. Suppose I open a file called numbers.txt, and so long as there's more data in the file, I'm going to read in the next int. Well, I have multiple problems that could happen in this situation. I could have a file not found exception, and I can deal with that. I could have a, oh, come on, I swear I have an animation. Here it's reading the file. If we were to handle this exception, it would get to this and it would crash because the word for is not a number. And so in this situation, it could have an input mismatch exception. And when you're coding, there's no possible way you can account for every possible situation. And so that's why we have these try catches. So in this situation, here's my single catch with multiple exceptions. Okay, remember when we did the scanner? The cool thing about the scanner is you can have multiple sources. You can have a scanner for the keyboard, or you can have a scanner for your file. So in this situation, I have a try catch, and my try is trying to open this file. So instead of having system.in, we say new file numbers.txt, and that opens this file. Then, so long as this is my scanner is called my file, so long as my file.hasNext, so long as there's more things in the file, it runs that code. It says my file.nextInt. Now this try catch will catch both the opening file if we have a misspelling here, and it will also catch if there's any text in the file too, because it's just catching one exception. It's just this generic exception that will catch every single error and print them out to your console. Now if you wanted to break it down, you can. In this class there's no need to, but I wanted to show you how to break down your try catch. This is the exact same code in the try, and in the catch, instead of catching a generic exception, I'm going to catch a file not found exception and an input mismatch exception. That way I could display different messages for different problems, and it helps me in my debugging. Okay, a finally statement will execute regardless of if there's an exception. So it will execute the try first. If the try has dangerous code and crashes, it will run the catch. But after it runs the catch, it will still run the finally. So this is a good place to put your myfile.close. So suppose this does run correctly and there is no division by 0, it's 5 divided by 1 or something like that, then it would skip the catch, but it would still execute the finally. So that's what a finally is. A finally is no matter what, run this code. Okay, to open a file, I've already gone through this, but I've shown you this in a super quick example, but I also wanted to describe every single element of that code example that I've shown you. So whenever you're reading from a file, you have to have a file. So here I have file, my file equals new file, and then in quotes I put the name of the file. And this has to be stored in this, so I have a names.txt. Names.txt would have to be stored in the same directory as your .java file. If not, you'd have to put the entire path to the file. Okay, there's a couple of file methods. So in this situation, the file is called my file. So if you wanted to see if that file existed, you could say myfile.exists. That would probably be in some sort of if statement because this returns back a true or a false. I could say create new file, and so it would actually create that file called names.txt. I could delete that file. I could say myfile.delete, and it would delete that particular file. So here's an example. Here's I've got file, my file equals new file names.txt. So there's the file, and it's just naming the file. Hasn't actually opened it yet. Then I have a try catch that's catching a generic exception. That way it will run my code. And then I say if the file exists, there's a not right there. So that's saying if the file does not exist, then create the file. So no matter what, even if there is no names.txt, the file would actually be created regardless. Okay, now the scanner's used for keyboard input. And I want to show you this because the scanner makes reading from the file super familiar for you because you've already done it before. Normally we say scanner, whatever it is, equals new scanner system.in. We usually prompt the user for a number or a word or a double or a sentence. And so I have the next int, next, which just reads the next word, next double, which reads the next decimal number, and next line, which reads an entire line. Those methods are also used for files. The difference is instead of putting system.in here, you put your file. So either my file, or you could actually say new file, names.txt, something like that. So you'd swap that out, and I think I have that on the next slide. I do! Look at that! Hey, so here's the same exact code, but instead of reading from the keyboard, it's reading from your file. So I've got scanner equals new scanner. This right here is a file. Remember, we have the file type, file, my file equals new file, whatever the file name is. So that's just a parameter of our scanner class. And this, now if I were to say int num, num would be reading the very first element in that names.txt file. Okay, so just wanted on this one, I just wanted to show you we are using the scanner, which is awesome because you are already familiar with how to use the scanner, and we are already familiar with those methods. It's just now, instead of coming from the keyboard, it can come from your file. Okay, whenever you use the scanner, it does have to be in a try-catch because this is what's opening your file. So here I've got file, my file equals new file, names.txt. You could actually put this into the try-catch as well. Then it opens the file. It will catch a file not found exception, or if you want to just catch a regular catch-all exception, you could just put exception here. Scanner methods, haven't I already done these? I think I've already talked about these. Oh yeah, these are the ones we already know. Let's show you some new ones. There is a, so you've already know next, next line, next double, and next int. There's also a close. You don't have to close the scanner for the keyboard, but you do have to close a file. So it just closes your file when you're done. Has next determines if there's anything more to read in the file. Remember, it's sequential access, so you read the first element, and then you could just keep checking. Is there more to read? Is there more to read? Is there more to read? If there is, keep reading the file, so it'll go down and access that third tennis ball in that cone of, that's not a cone of balls, tube of balls. All right, so has next just determines if there's anything more in the file to read. Okay, here is an example. What this does is stores data from your file and puts it into an array list. Just wanted to show you this really quick because you're actually going to be using this same file in class for the try it out activity. What do we call those? The little collaborative practice activities. So I wanted to go through this with you first so you would be familiar with what you currently already have. All right, so here it's opening a file called groceries, groceries.txt. There's an if statement on it that says, well, if the file exists, then open up the scanner with that file name and keep reading it so long as there's more elements in the file. If there's more elements in the file, it's using our next line, which reads in a line of text, but it's instead of reading it from the keyboard, it's reading it from the file. So it's going to read in eggs and then add eggs to the groceries array list. Then it's going to read in milk and it's going to add milk to the groceries array list. Then peanut butter, and then it's going to add peanut butter to the groceries list. And donuts, of course, we have to add donuts to our list because what would a grocery list be without donuts? As soon as it finishes reading the last line and adding that to the list, it will fall out of this loop and then close the file. Here I have a little else statement in there that says, so going back to this if statement, if the file does exist, it reads it in. Otherwise, it creates it, and it would just create a blank file with the name groceries.txt. Seriously, did I spell groceries wrong? Is that how you spell groceries? Dang it, I'm going to have to change this whole video. No, I'm not going to do that, but yeah. All right, so right now that just reads from a file. If you want to write to a file, that's a little different story. You have to use what's called a print writer. A print writer writes to the file. The scanner reads from the file or scans the file. I like to use the word, the actual definition of the word. So here I have a print writer, F out, And I usually use F out, that's usually what I name it, just because then it's similar to a system.out.print, only instead of system.out.print, it's going to be F out.print. Because this print writer works really similar to a system.out.print statement. So here I have a print writer, F out equals new print writer, and in parentheses, instead of a file, I'm going to create a file writer of whatever the file name is. So in this situation, remember I talked about an F out statement being similar to a system.out.print statement? There it is. This would print an entire line of text. This would just print to the next position in the file, be it on the next line or next character or what have you. So this file would print out a 5 and then a 2 and a 3, but it would kind of look like this because the print line prints an entire line out, but the print just prints out to the next space. And then the fout.close would close your file. Oh yeah, here's the close file. Make sure you close your file every time you open it. So here you open it, and you make sure you call your fout.close. And that is it for files. Good luck with that. We have a pretty fun no-brainer that is now posted, and we will see you in class.